on Saturday. That is depressing.
Monday?
That'd be more likely. I've just what my life where I don't practice things on Saturday. If I don't, I might be good enough to do it today.
I think you should do Monday because my weekend would be so much better.
You think?
Yeah.
I don't think it was bad. I don't recall.
Really?
I don't recall. There are number strip left at your table. No, they okay. They did. They just it's out of my reach. I don't know. Okay, let's go ahead and get started. Yesterday we were on a new packet. If you weren't here yesterday, did you get the new packet out of the thing in the one? Perfect. We are moving on from HCs. We are on quadratics. The two bell ringers today are actually a little out of our league because we haven't talked enough about quadratics for them to necessarily be okay. We can fake it till we make it with 17. We'll fake it with 18 tomorrow. We can figure 17 out. It's just going to require a little patience. Okay, you got out your number strip. You're ready to roll. It's in the top drawer of your thingy if you've already forgotten. Okay. On 17, ignoring that equals 0, is there a number I can factor out of everything? Or some sort of GCF? Yes, dear. Tell me the answers.
You can factor out 3x squared.
No, do you have the actual x equals those 5 answers? Okay, get those 5 answers and tell them to me. Lanny, go ahead and tell me what you want to tell me.
I was going to say you can take out 3x squared.
You can have the point for that. Okay, if we take out a 3x squared, we're left with an x to the 4th minus 13x squared plus what? 2 and 4 get another point. And that's great. And you're like, okay, well, we're done. That's not true today, sadly enough. So before our directions just said factor, and literally once we did some sort of factoring, we could call it a day. Today our directions say solve. And another reason why we knew we were going to have to do more is not only the word solve, but the fact that it has an equal sign and a 0. So we're going to have to keep going until we get answers, like x equals 0, x equals 4. We need answers. Okay, but we can actually factor this. Doesn't look like it, but it will in a second. What if we change this problem to, got rid of some of those exponents. What if we change it to x squared minus 13x plus 36? How do we factor that? Needs to add to negative 13 and multiply to positive 36. Yes, 2 and 3 get the point. Negative 9 and negative 4. Negative 9 minus 4 is negative 13. Negative 9 times negative 4 is positive 36. This is all completely correct. However, still not done. Top drawer, Brady. Look in your top drawer. Everyone has their own set color now. Okay, so that's great, except how does that relate back to what we were doing? So let's write that 3x squared again. I'm still going to put the negative 9 and the negative 4. But we had x to the 4th, not x squared. So what am I going to put here and here? Yes. Jessica gets the point. Now, if we're questioning Jessica's sanity, which is not a bad idea because this is new, we could FOIL it out. X to the 4th would be our first. Negative 4x squared minus 9x, that's squared. That's how we got the negative 13x. Negative 9 times negative 4 did give us the positive 36. So she's not crazy. And if we wanted to, we're actually still not even done factoring. We can factor this further, can't we? Tell me about that x squared minus 9. What could we break it up into? And? Ooh. X squared minus 9. That's a perfect square. 9's a perfect square.
X plus 3.
Yes, it's just supposed to be x minus 3x plus 3. It's a perfect square. Brady get another point. And then, so what should we do with the x squared minus 4? Yes, we're going to have the minus 2 and the plus 2. We'll come back to this line in a minute. and we'll talk about how I knew the answer from here. So I didn't have to do the difference of perfect squares. But heck, we've done a lot of practice problems with the difference of perfect squares lately. So yeah, Landon didn't know how to do this entire problem, but he did know how to pull out a GCF. He does know how to factor when it's a leading coefficient of 1, and it was kind of like having a leading coefficient of 1. He did know how to pick apart the perfect squares. So this is the first, really, I'm going to call it brand new step. Since it does say solve, we need to set each of these 5 factors equal to 0. So I'm going to set each of these things equal to 0. So I have 3x squared equal to 0. I have x minus 3 equal to 0. I have x plus 3 equal to 0. I have x minus 2 equals 0. And I have x plus 2 equals 0. So I actually am going to end up with 5 answers. Okay, you're like, Ms. Compton, that sure does seem like a lot of answers. And it's actually not. So if we look back at our original problem before we try to figure out what those 5 answers are, if we look back at our original problem, our problem was 3x to the 6th. Now you and I have only dealt with like an x to the 1, so there's 1 answer. X to the 2 has up to 2 answers. X to the 3 has up to 3. So x to the 6 actually could have up to 6 answers. So we only have 5. We're missing an answer. Okay, so let's go back to these. We need to figure out the answers. X minus 3, if I solve, I end up getting x equals 3. We'll give 1 the point. And so I also have x equals, and x equals. Okay, and I'm going to give out another point if you can tell me a better way to write this. Like x equals what would summarize 3 and negative 3?
Yeah.
I'm going to do, thank you, DJ, I'm going to do the plus or minus. So plus or minus 3, plus or minus 2. And that way it's just taking up less space. So we've got 1, 2, 3, 4 answers. We've only got to get that 5th answer left. What is that 5th and final answer? Ready, get the point. If we divide by 3, we would have x squared equals 0. If we take the square root of both sides, the square root of 0 is just 0. So it's just 0. Okay, so those are our 5 answers. And I'm going to leave those up there. I'm going to zoom out and see if I can show all the things at once. I can. Okay. I knew those 5 answers from this step. I knew this one was going to end up being 0. I knew because the x squared minus 9, I was going to have a plus or minus 3. I knew since it was an x squared minus 4, I was going to have a plus or minus 2. So if you need to keep on going and then set each of the 5 equal to 0, you can. But if you realize, hey, I know the answer sooner, that's great. Stop. Give me the answers. Not a big deal. Okay, are there any questions about 17? Again, it was a little out of our league. We just had to grin and bear it. Okay, let's go back to our notes from yesterday. We're talking about quadratic functions. We're trying to be a little lazy since we're behind. So we're skipping a couple steps. If we read the directions, it says that they want us to graph it. They want us to give a table of values. We're not going to do those things. Instead, we're going to make a list of the same 6 things we were making a list of yesterday. Any problem I see, I want to know the y-intercept. I want to know the axis of symmetry. We're going to do number 4, by the way. I could have said that. It's page 2 on the back. I need to know the vertex. I need to know if it's a min or a max. I need to know the domain. And I need to know the range. Okay, so these 6 characteristics tell us about the graph. And if we could list these 6 things like we were doing yesterday, once I know these 6 things, I can make a graph. If I know where that axis of symmetry is occurring, if I know where that vertex is, I know where that intercept is, suddenly, all of a sudden, I've got a parabola graphed. So knowing these 6 things helps me graph. We're just being kind of lazy, and since we are graphing, that's not at all right for this problem, by the way. We're just being kind of lazy, and since we are using our graphing calculator, we're not taking the time to draw our own graph by hand as well. Yes, dear?
We
Yes, in my drawer under my seat. The one with a little keyhole on it. Okay, so the one with the keyhole on it, the one under my seat, my chair. Sit in the chair and then pull out that drawer.
Oh.
Okay, there you go. Okay, so there are some things that I know without using my graphing calculator. Can you tell me one of the things I should know without using my graphing calculator? I know the y-intercept is where? Yes, so I'm going to say 0, negative 12, but if you just put negative 12, that's also correct. What else do I, you can have a point for that. What else do I know automatically? I might can know that because there was a formula for it, so I could plug it in the formula. Did you do so? So if you wanted to, you could calculate that. We'll come back to that in a second. Domain. What is the domain? Yes, 1 and 4. Okay, like I said yesterday, 95% of the time, maybe even higher than that, 95% of the time, we're going to put that as our domain. The only time we're not going to put that as a domain if they turn it into like a real world problem. And we hadn't been doing any of those. If you look in the 1, that's why I asked to begin with. You tune me out, but it's okay. I love you anyway. Because yesterday was November 1st. Okay, so go press y equals on your graphing calculator. Turn it on, press y equals. And then you need to press clear or delete because you got to get rid of whatever last period did. You don't need their work. We need to type in number 4 as negative x squared minus 12. So negative x squared minus 12. I press graph. Is there anyone who can't type that into y equals or is struggling with that? Okay, so you press y equals. Come on, y equals. I did the tiny negative, so negative. My x button had the xt theta n, so x. Then the squared button, which is below the x to the negative 1, so x squared. Then the minus button, then 12. So it ends up looking like this, negative x squared minus 12. Okay, if you press graph and then nothing happens, you're not the only one. Notice my graph is not really showing up either. We talked about how to make it fit our graph better. We press zoom, and then what would help it fit your graph? Standard. I like standard, and what's the other one I like? Because zoom standard didn't do anything for me, because I still don't see anything. Zoom, and then what? What's the other one I like? I like zoom decimal. I like zoom square.
Zoom fit.
I like zoom fit. Why do I like zoom fit?
Because that didn't fit to your graph.
Yes, and you can have a point for that. I like zoom fit because it fits my graph. Now, I'm not saying it's pretty, but literally it fits your graph and makes sure your graph shows on your screen. Okay, so the only reason why we graphed it at all, because heck, we have already got the intercept, we've already got the domain. We're trying to figure out the axis of symmetry, but the second we know the vertex, we're going to know the coordinate for the axis of symmetry. The second we know the vertex, we're going to know max min. The second we know the vertex, we know the range. So all we got to do is figure out where that vertex is. And there's one other obvious thing you didn't tell me to begin with that you ought to tell me. On that list of 6, there's one more thing we can fill in without pressing any more buttons. What is that? Is it a min or is it a max? Look at your graph. What was it, a min or a max? Okay, and I didn't explain this well yesterday, but I'll explain it now. If it's a positive number in front, it's going to be a min. If it's a negative number in front, the way ours is a negative x squared, it's going to end up being a max. Negative ones, flip them down, the way it did with absolute value functions. So that's why it ends up being a max. Okay, since it's a max, I know what I'm looking for. So I press second table, and what do I look for on that second list of my table? What am I looking for? I like whole numbers, but I see lots of whole numbers. How do I know which one to pick? It's a max. So are we looking for the smallest number or the biggest number? The biggest number. That makes sense. So what is the biggest number you see in that second list? And you can scroll up and scroll down to figure it out. Negative 12. So that means my vertex is at 0, negative 12. because the biggest number I saw on my calculator screen was negative 12. So my vertex is at 0, negative 12. Which means my max is the y number in that vertex, so it's at negative 12. My axis of symmetry is happening at 0. And something curious has happened. My y-intercept and my vertex match. Okay, so go back to that graph. So we said the axis of symmetry is x equals 0. So if I gave you a pair of scissors, where would you cut this graph? Down what? Down 0, but that's also the y-axis. So it's weird. We're cutting down straight down the y-axis. And our intercept is actually happening on the y-axis. So really we have, and it's not showing it well because, you know, we did a weird zoom. We start at negative 12, and we're going straight down. But if we were to cut it, we would be cutting down that y-axis. Okay, I need to know the range, and we've done all the things. Is it negative 12 infinity? I can touch it all the way until negative 12. So I'll give you that negative 12 is involved. Yes, and you can have a point for that. Negative infinity until negative 12. Once we hit negative 12, then we're done and we can't touch it anymore. Because that once I hit negative 11, look, I'm reaching left and right and I'm not touching any part of the graph. Yes, dear.
Why do you do braces on one side, bracket on the other?
Remember we talked about that before. If I can touch it, I put the bracket. Since I can literally touch my graph at negative 12, I'm putting the bracket. Remember the holes, but when we were doing piecewise, if it was an open circle or closed circle, it's that kind of thing.
But like, can't you keep, since you keep going down until negative infinity, keep touching?
Can you actually ever touch negative infinity, or does it just always get bigger and bigger and out of your reach?
Well, yeah, but
So you can't actually physically put my finger on infinity, whereas I can actually, boop, negative 12. You can't touch it, don't put the bracket.
okay.
Yeah, you're going deep. I like it, man. You're going deep. Okay, so that was great, and everything worked out well. And we're actually going to skip number 5 because I think you got it under control. We do have a slight issue, though, which we discussed yesterday. That table lets us down. Why does the table let us down? It's only whole numbers, 4 gets the point. So we talked about, since this table is only counting by ones, you know, negative 4, negative 3, negative 2, we can press second table set and change it and make it count by like halves, but we're still just guessing then. So the better way, if it's going to end up being a decimal or a fraction, is to press what button besides table? Calculate. So we're going to press second calculate, and you can have a point for that. So let's go do another problem. Guess what? I'm personally going to pick one that's going to end up being a decimal, and we're going to have to press second calculate. So we're not going to do number 5. We're going to do on the next page, page 3, number 1. And I just can't stand it when they're not consistent, this consistent list. So I'm going to change that bottom one to y-intercept. And there's something missing from my list. What's missing from my list that I normally like to list? If I know 1 and 2 said it. Anyone else? 1 and 2, 1, 2, and 5 get the point. 1, 2, 4, 5 get the point. So I'm going to add that to my list. Literally, Miss Compton's going to list the same 6 things every single time because I'm a creature of habit, and I like it that way. Okay, but before we even go crazy and start worrying about where the decimal is and why, there are some things I can fill in. Yes, dear. Okay, and what is the y-intercept?
4.
Okay, so I'm going to put 0, 4. If you just put 4, that's fine. And then the domain is, and you can have a point, Travis. And we know it is going to be a maximum, and you can have another point for that. Okay, so, but now we've got to figure out, I wrote that at vertex instead of at y-intercept. Why did I do that? Strange. Thank you. Now we got to figure out the rest. So, if you graph it, so go back to y equals, clear out what you did before, type in negative x squared minus 3x plus 4, press graph, and my zoom's all out of whack, so I'm going to see if zoom standard works, because whatever I got it zoomed on is not working. Zoom standard did a pretty good job for this one. I'm thinking the axis of symmetry is at, I mean, if I guessed, I would say negative 1.5 because negative 2 is a little too far this way, negative 1. But I don't like this just guessing thing. I don't like that.
And also, that's not like one of those.
So, if you're like me and Brady, if you notice that since I'm thinking it's negative 1.5, I'm already anticipating that the table's going to fail me. But for those of us who doubt that the table will ever let them down, let's look at the table. Second table. So it was supposed to be, if we look back at the graph, yes, it is supposed to be a max. So when we press second table, we're really looking for the highest number in this table, and we have a problem. Houston, boy, do we have a problem. Why do we have a problem? It has two answers. What are the two answers? Yeah, I see 6 twice. So someone last period was like, well, can I just take the average and say it's negative 1.5 kind of comma 6? And it ends up being correct on this one, but should we always bank on that? No. What if it's not exactly in the middle? We don't know. So the table has failed us because the highest number is happening twice. So we're like, I don't know. It's that I don't know which one of those is the vertex. It's not helping me. So instead, press second, calculate. We decided it was a maximum, so we want to press max, which is number 4. And I don't know if I did this well yesterday or not, so I'm going to do it again today.
Ms. Compton,
Yes, ma'am.
do you have David Douglas?
Yes, ma'am.
Would you send him up to the teacher workroom, please?
Yes.
To see Coach Murphy.
Yes, ma'am. Okay, so you see the monster cursor blinking? And I don't know if I explained this well yesterday or not, but what we're trying to do is guess this exact point.
What is it?
Do you know where the IC room is? Go in the 200 hallway, go past the library, it's on the right before you get to the office. Okay, so we're wanting this, and we've got to guess it. So our calculator is very smart, and our calculator is so smart that our calculator can graph even harder things. Like, what if it was like the McDonald's arches? What if there were 2 maximums in our graph? We can't help it. We have an easy graph for it to handle. It doesn't know. So it's prepared to handle hard stuff too. So we literally, even though our picture only has 1 maximum, we have to tell it bounds. So when it says left bound, they're meaning to the left of that point that we want. Now, it doesn't matter how far left you go. You can go right there just slightly past it, or you can send that little monster cursor way on. Doesn't matter. And then once you press enter, it shows you where you set it. So when we set our right bound, we're going to go to the right side of our dot, or where we're wanting. And it doesn't matter how far down you go. And again, we press enter. And it shows you at the top of those arrows your region. Like I'm saying the max calculator is between these 2 things. Can you tell me exactly where between those 2 things? So if your calculator fails, knowing you set the region wrong, and your max wasn't actually in that region. Yes, dear?
I didn't know I did everything I did max it, but it already put the X in the area.
It did?
Yeah.
You pressed when you pressed maximum. Yeah, it kind of guesses there to begin with, yes.
Yeah.
And that's why I move it a little to the left and a little to the right. And I moved it a lot so I could show you the parameters. You can do a really tight restriction. It doesn't matter. Now, if I could redo calculators, I would redo this part. It makes you, after you set the left bound and the right bound, it makes you guess, which I don't understand, because it's going to fix it. So you can, I have this girl last period, she's really particular. So she made her guess, like, as spot on as she could. Like, I think it's there, I'm going to press enter there. You really don't have to. You can press enter pretty much anywhere. Like, my monster's nowhere near the max. It's still going to tell me the right answer. So the guess part, I think, is dumb. Okay, so I press enter, and it tells me my maximum is at negative 1.5, 6.25. Which means, since my max happens at my vertex is negative 1.5, 6.25. So let's go look at our paper. We can now fill in some things. I know my vertex is negative 1.5, 6.25. I know my max is at that 6.25. Well, let me see if I can show both things by moving. You need to go over here. You need to sit here. Okay, I know my axis of symmetry is at x equals negative 1.5. which is what I kind of thought to begin with. And my max is at 6.25. So basically, once I know that vertex, heck, the x value is the axis of symmetry. The y value is where that max is happening. And that y value helps me with my range. So what is my range for this graph? Travis get another point. So negative infinity on up till 6.25. Once I hit 6.25, I can't keep touching him. Okay, and all that's great. Say what, dear?
Is the range always going to work out that way?
Yes. It's always going to be a negative infinity to either your max or your mid until positive infinity. Yes, always. Thank you for catching on to this process. Okay, so, but you get, if you like calculators, which I do, then this is great. But Landon can still do literally all of this by hand. So if he wanted to, he knows the formula for axis of symmetry is negative b over 2a. So it would be negative 3 over 2a. Well, a is negative 1. So it would be positive 3 over negative 2, which is negative 1.5. Lo and behold, that's what we had for that vertex and axis of symmetry anyway. If you took that negative 1.5, plugged it in our function, he would get out the 6.25, and he would have all the other answers. So while the calculator can save the day and give you all the answers, it's not like you can't do it by hand. You can. So it's really up to you. Okay, we're going to save number 2 for tomorrow because I just cannot fraction with you today. Let's go do number 3, and then I'll give you a chance to practice them on your own. Number 3. Make my heart happy and go ahead and fill in the things I can. Thank you. 5 gets the point. Y-intercept is 2 gets the point. And then there's one more thing I know before I go crazy. It is amen. Thank you. 4 gets the point. Okay, so let's figure out the rest. So Travis is doing it by hand. He can literally keep on doing it by hand. His laugh will be great. He already knows the y-coordinate of the vertex is negative 1.5. But for the rest of us who are calculator people, let's type this function in the calculator and see what happens. Negative 6, you think? I don't know. I don't remember. You said 0.5 or negative 1. It's negative b over 2a, so you're saying it's positive 1.5?
Yeah.
I don't know, I haven't graphed it, but yes, because negative 6 would be positive 6 over 2, so it is positive 1.5, yes. That's what he thinks. He might be wrong. He's been wrong before, no offense. It happens to the best of us. So 2x squared. He wants me to remember the answer like I remember all the answers. I do not. Minus 6x minus 9. I press graph. I can't really see my graph with Zoom Standard, so I'm going to press Zoom Fit. Although sometimes Zoom Fit is disappointing. Oh, and this one sure was. Okay, so Travis is calculating in my hand. That's great. I really wish it would work if I did my table. So since it's a min, I know I'm looking for the smallest number on my table. So I go to my table and I start looking. And what's the smallest number you see on your table? Negative 13. But there's 2 of them. Oh no, we're having the same debacle. So we could say, and Travis has already proved, yes, it is 1.5, so the average of the 2. But again, who wants to make this bet that for sure it's the average of the 2? I don't like that. So I'm going to press second calculate. I know it is a min. I'm going to set it a little to the left, a little to the right, and I need someone to tell me their answer after doing so. 5 gets the point. Okay, so if you're impatient like me, she obviously was patient. So if you're impatient like me, I made a mistake last period because I did not wait to find my cursor. So I did zoom fit. So there's a lot of parabola down below that I can't see. So when I press my right bound, I better make sure I actually see my monster cursor blinking again before I press enter. Because otherwise, you send it to the great beyond. You don't know what you're pressing enter at. How do you don't know. You need to see the cursor before you press enter. You can make a terrible guess. And yes, 1.5, 13.5 is the answer. She was correct. So 1.5, 13.5. Negative 13.5. I can put the negative sign. I've got this. Right? Hopefully. So Travis was right. The axis of symmetry is 1.5. But now we've proved it with our calculator. And our minimum is at negative 13.5. And then what about that range?
Negative 13.5.
Yes. So we start touching at negative 13.5, and then from then on out, we can touch it forever. Let's say that again. I can touch it forever up here. It's just I can only go so low, and the lowest I can go is negative 13.5. Okay, are there any major issues with this? I understand that a lot of you will not be here tomorrow. That will be fine. We're going to do a couple more examples like this. I'll post the video. What we are going to do today, and when we do at the end of class tomorrow, and it's fine if I don't see it till Monday, if I don't see your face tomorrow, is page 7. Because of the game tonight, and life's late, and I understand all the things. Okay, if you flip 2 more pages in your notes, there's a page 7. I guess I was having a moment, I don't know. The thing on the top and on the bottom is exactly alike, so cross off the bottom one. They're exactly alike. Now, again, we are trying to cut corners, so we're not going to do all the steps listed there. We're not making a table. We're not actually going to graph it by hand because we're graphing it on our calculator. So seriously, I need the list of 6 for each problem. So there are 6 problems, and I need the list of y-intercept, axis of symmetry, vertex, min, max, domain, range. I need 6 things for 6 problems. So are you surprised that this is going to be worth 36 points? Yeah, 6 times 6 is 36. This is going to be new at the end of class tomorrow, and just to annoy you, I guess, I really wasn't trying to annoy you, it's just all the things at once, there is also a checkpoint. We will have time to work on both tomorrow. If I'm not going to see your face tomorrow, I would love to have both done by Monday. You know me, I will probably type in the zeros Monday afternoon.